Hello everyone, this is KP the Math G, and yeah, it's been a while since I've done a YouTube video. I'm going to finish up the way I've got it set up. I've got 156 videos. My goal is to reach 160 videos of calculus and then probably get into other topics like college algebra or some other type of thing, trigonometry, whatever I would decide to do. And maybe even some more. If you want to request that, I'll do some more YouTube and AP calculus. I enjoy doing that. Most of these, all of these actually are AP calculus problems. And of course there's a lot of overlap now because I'm doing a lot of problems from different tests. And so yeah, I'm thinking probably 160. I may do more, but right now I'm at 100 and going on my 157th video. But let's go ahead and get started. Enough of the video talk. Let's go ahead and start. This is the 2022 free response question number 1. I kind of abbreviated this, so I'm going to kind of read this out to you. It says, from 5 a.m. to 10 a.m., the rate at which vehicles arrive at a certain toll plaza is given by A at T is equal to 450 times the square root of sine of 0.62 T, where T is the number of hours after 5 a.m. and A at T is measured in vehicles per hour. Traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. Of course, some of this writing has to do with parts A, B, and C, but I'm going to do just part D. Part D says this: a line of vehicles forms whenever A at T is greater than or equal to 400. The number of vehicles in line at time T, for T being between A and 4, including A and 4, is given by the equation N at T is equal to the interval from A to T, little a to T, then capital A at T minus 400. Well, A at T is this, okay, dx, where A is the time when a line starts to form. Find the greatest number of vehicles at the toll plaza in the time when T is between and including A and 4. And justify your answer. Okay, there are some things that we need to look at when we are observing a problem like this. One of the first things that I find here is, well, here's the rate, but now so we're giving here this interval, which is the number of vehicles here, is given at this time here on this time interval here. But now let's just look at a few things here that are very important for us to consider. First of all, we need to look at what A is. A is the time when a line starts to form. So I want us to look at that. A is the time when a line starts to form. Alright, so you're going to start at A. Alright, and that's what we're talking about. A, whatever we find for A, right there. And then find the greatest number of vehicles. The greatest number of vehicles. Right there. That is going to be EVT immediately. To me, in my mind, that's a candidate's problem. And I'll show you what I mean by that. Okay, so EVT means you look at the endpoints. Alright, that's the extreme value theorem, where you look at the endpoints and critical numbers, if there are critical numbers. And ever which one yields the biggest N at T, you plug those in at N at T, and then the endpoints and the critical numbers here, and then you find out which one is the biggest of the three. Well, there are going to be three in this case. Sometimes there's 4 or 5 maybe. but in this case 3. Alright, so we're going to look at that in just a moment. Alright, so we're looking at A, the beginning, and then maybe some critical number in between A and 4, and then 4 itself. So that's what we're looking at. Alright, so let's look at this here. I'm going to say for the time, here's what we're doing here. Alright, so we have to go back and forth. Now this is in at now here in at T. Alright, in at T, which by the way happens to be let's see, from, it's equal to from A to T. Alright, yeah, alright, A to the T minus 400 dx. Alright, now that's what we're going to be doing. We're going to be finding 3 of these. Alright, that's what we're going to be looking at. Alright, actually I don't need this much, so I'm going to need room to work, maybe a little bit. This is a calculator type problem, so I want you to be familiar with how you can put this into your calculator, and that's basically what I want to be able to show you. Some of you may be even more adept than I am. I've been out of this for a few years now, and and there are more advanced calculators than what I've got. I think I've got a pretty advanced one though. So I'm going to kind of show you how to get started with this. Okay, so we know that, let's see, first of all it said back here, let's just go back again. Now, the greatest, let's put the interval up there. Alright, so let's go ahead and do that. The interval is from A less than or equal to T less than or equal to 4. Alright, so that we got that. Alright, so let's see now. What do I need to do? And then it says greatest number. So greatest number. Alright. Alright, and so what we're looking at is an absolute maximum. That's what we got to understand. From that phrase, greatest number, we're looking at an absolute maximum. We already know that there's A, and we already know that there's 4. We need to find this critical number right here and put it here. As I said, there's 3, and I'll show you in just a moment from that. Okay. Alright, so now let's go back to the problem here. Okay, I'm sorry I keep going back and forth. That's about the best I can do. I wish I had a big long board where you could see the problem on one end and then we'd come back and forth, but that's okay. Let's just keep going back and forth. Now what I want to do here is I want to put I had to practice a little bit because I was kind of out of practice. But anyway, it's kind of like a bicycle. You get on it and you just go on it again. But with calculus, it's a little bit harder. So you got to keep on with calculus, otherwise you're going to forget it. Okay, now let's see. I want to show you that you need to go to math. All right. No, I'm sorry. That's not what you do first. Hold on. Let me get out of that. Not math. Okay, well, I just lost my calculator. I got to get it back. Here we go. Alright, now y equals, and I don't know if you can see that or not, but I have this function right up here. Let me see if I can put it in here where you can where I can see it, and then I doubt very seriously you can see that. Alright, but what I have up there is this. I'll just have to write it down. I'm sorry. What I have here is I have this part right here, but then again it's the same thing. n at t is minus 400. So what I have here, okay, what we have to understand here is that I've got this in there. That's the first thing you need to do, is put that part in there. So really, if you want to do it this way, that it happens to be now a at t is, remember, a at t happened to be 450, all right, times the square root of sine of 0.62 t. All right, so you want to put that part in there, but then again you got minus 400 here. Okay, so this is what I've done. I have on my calculator y sub 0. You might have on yours y sub 1, but I'm going to go with y sub 0, and this is what I'm doing. I'm going to put this in there. I put this right here. I'm just going to say y sub 0 is this sine of 0.62 t, and make sure that that goes beyond, that the square root symbol extends all the way to the t, and you can close that off with parentheses, and then minus 400, and that's what you want to do. You want to have that already stored right there. Put it in there. All right, now that takes care of that. Now, when it talks about an absolute max, you know, you're looking for, on a graph, you're looking for the absolute. Now there's maxes. We're looking for the absolute max. All right, and so this is the absolute max here. It's going to be where this, and actually when you talk about this, you're taking the derivative of this, okay, and then you're going to set this equal to 0. So let's do that now, okay, because this right here, this represents the slope, remember, and an absolute max, that's going to be, your absolute max is equal to 0, right? All right, so your absolute max is equal to 0. All right, so there it is. All right, so that's what we're doing. Oops. So absolute max means I take the derivative. All right, so you have to be able to interpret that. Oh, I'm taking the derivative of this. So this is what we're doing here. So n prime at t is equal to, really all that does is just remove this, isn't it? Doesn't it? Okay, so really you're saying from a to t, okay, I'm just going to go ahead and go through it anyway. All right, dx, and we're taking the derivative of that. Okay, when we take the derivative of an antiderivative, it's just that, isn't it? So what we have here is this, a at t, minus 400. Now remember, we're setting that equal to 0. Okay, equal to 0 because we're looking at the point where the max is, the slope is equal to 0 there. All right, absolute max means that, right? All right. So the slope is equal to 0. All right. All right. So that is what we're doing here. All right. So now what I want to do on that is, I'm trying to think what I did on this. Okay. Now let's see. Okay. So I want to graph this part right here. So once I get this in the computer, I hit the word graph. Oh, and I did not. Let's get back to y equals. Yeah, I did. Okay, I graphed it. Okay, there it is. And on my calculator, I have the word root, and I don't know what you have on yours. I may say 0 or whatever. It's where it crosses that x-axis. Then once I punch that, my numbers show up. So what I have are both A and B here. A, and I'm going to call this critical number B. I have two places in between 1 and 4, or actually between A and 4 rather. Okay, so this is B. I'm going to call this B right here, and well, this is going to be a let's move this over a little bit. B is equal to, all right, so 3 point, well, we can just put B here. All right, we can do that right there. Sorry about that. Okay, so let's see. A happens to be on my calculator. When I hit the word root, okay, I get the number, let's see, 1.46937. 1.469937. That's A. All right, and then B, that happens to be 3.59771. 3.59771. Now, if you label this and you put A, B, and 4 here, that is perfectly okay. All right, that's perfectly fine. All right, so let's see here. Probably, it's going to be all right. We're going to extend it out. My blue seems to come out better than my black does. All right, we're just going to do like that. Okay, there we go. All right, let's go ahead and let's understand that all this, by the way, happens to be t. All right, it's all time. All right, all of this is time, and that's why I have this division here. All right, time t. All right, now that I have these numbers here, I can start to plug in in place of t right here. A and t, by the way. So really what I have here is this, okay? So A happens to be 1.466937. All right, and so the next one is also, it's from A to A, right? We could very easily say, and I'm just going to put here A at t minus 400 and dt right here. All right, when I'm integrating like this. Okay, so now when I do this right here, you know that if you have the same thing on the bottom as your top is, then the answer is obvious. You know what that is. You're actually going from A to A. Some people, you can just say, once you already label that, you don't have to write the number down. You can simply say from A to A. All right, so that's the first case, starting from A to A. Well, that's obvious, it's 0. Okay. Now we're going from A to B. Still, that's the, and you got to remember A. Why are we starting? That says A right here. This says A right here. This is what we have as A. All right, so I am going from A, which happens to be, what is it? 1 point. If you want to put that down, you can do that, but you can just put A there. It's just as good. 937, and B happens to be, now we're going to try our critical number. So let's see, 3.5.9771. It's good to go out and extend that all the way out so you can get a more accurate answer. So that's what you're plugging in. Now, by the way, all of this happens to be where I stored it. Now I stored it in y sub 0, so I can just simply call up this y sub 0, all right, like this, and it's going to say dx, but anyway, y sub 0 here, and on the calculator it'll say dx. That's okay. We know that it's really t because we're looking at time, aren't we? All right, so anyway, so I've already done that, okay. And when I did put that in there, okay, this first one like this, I've got 71.254. Now 71.254. 71, and actually it said round to the nearest, so this thing is going to be, it is about equal to 71.254. Now remember, in calculus, AP calculus, you go out 3 digits. But remember, in this particular case, it's asking to round to the nearest whole number. So in this case, we put 71 right here. Okay. Now you got to remember that this graph is since you have it to be differentiable, we know that it is continuous. Okay, so you might want to say that, but anyway, that's what I'm saying verbally. Okay, but anyway, that's the case here, and you can just go ahead now. B, what are we putting here? That's all we're saying. We're going from A to 4. All right, so A to 4, that's about equal to, in this particular case, 62.338, 62.338, and that's going to round up to 62. Now, you have three answers: 0, 71, and 62. My oh my, just pick the one that's the biggest one. It's 71. That's the greatest number of cars during this period of time. Okay. Alright, so let's erase this. And always remember too that when you are asking, when this thing asks for, the greatest number of vehicles, I know this is EVT. I know I'm checking the two endpoints and any critical numbers. Sometimes it's more than one. In this case, it's only one. Alright, so this was my critical number right here. This is a critical number. This is actually the endpoint. Okay, so you have to try the endpoint first. That's what we did. So that's what we did when we went from A to A in at T dt. Alright, so we got 0 on that first one, right? Remember? Okay, and then now we went from A to B, and I'm going to put down what we got rounded up, 71. And then we went from A to 4, the other endpoint, and we got something like 62. Alright, and that's what I'm talking about. Okay, alright, so that's the three that you've got to check out, and again, you do that by a calculator. Okay, really, it's very difficult to do this by hand without a calculator handy anyway. So anyway, instead of typing all this out each and every time, you can just simply just make this A at T and make this your Y sub 0 or Y sub 1, wherever it starts on your calculator. And just put that in there from the start, and then graph that, find the root, or in this case maybe the 0, the root. Okay, and that should tell you what these two, mine just showed up immediately. Okay, and that's what you do from there. And once you get these two, you kind of get a sigh of relief. At least you have those, and then now once you can plug those in, all three of these, into this interval here. Okay, alright, and that's it right there. Now, the answer, of course, we need to write it down, don't we? We need to make it official. So, let's see. The question is the greatest number of vehicles. The greatest number of vehicles. At time t. And you might always want to say that. Or on the interval. Or on the interval. On the interval. Let's say that. On the interval. Let's see. Well, A, yeah, T, and then 4, occurs at whenever T is equal to B, which is about equal to, let's just say about equal to 3.59771. And of course we find that this yields, okay, is 71 vehicles. Alright, there you go. Just to recognize that this is a candidate's problem. That's what I mean by candidates. We got the endpoints. This is EBT. Alright, and you will see that quite frequently. I imagine by now you've already taken your AP calculus exam. If not, at least you have this one to look at before you take it. I don't know when that test is, but needless to say, if it's over, it's over. But at least we got those of you who are getting ready for next year. Look forward to this kind of problem right here. You'll see it, but there you go, right there. All right, and so that's all we need to look at here. 71 vehicles. All right. Again, KP the Math G. What I'll do in my next video, I will probably do parts A, B, and C, depending on how fast I can go with that. But that part D did take a little time, didn't it? KP the Math G is about ready to sign off. My wife is probably waiting for me to cook some of that hamburger meat. I'm probably going to make some hamburgers. And so anyway, doesn't matter to you, does it? This is not, again, for my glory, it's for yours. Okay, I'm about ready to sign off here. Just make sure that you subscribe if you have not already subscribed to my YouTube channel. Also, you feel free to make a comment if I've done something incorrectly or I said something that some of the jargon was incorrectly. Let me know, and I'll correct that from now on. But please make a comment, good or something constructive, as long as it's nothing, just don't say bad things. I mean, just be constructive as much as you can if you have something constructive to say. I do appreciate that. But then hit that like button. I always smile when you hit that like button. I'm already smiling now. Anyway, be that as it may. KP the Math G signing off. Ladies and gentlemen, have a great, great day.